I'm going to go live now. All right, welcome back. We are COMP397, that's web game programming, in the winter 2021 semester at Centennial, and it's week 2, part 2 of our broadcast. And right now, we were talking about simple scripts that we added in. We talked about the input manager. There's different ways of getting input from the input manager. You can get input.key, deep input.button, input.some kind of virtual access. And I've given you some default static methods you can use. We've used getAccessRaw right now as an example with no smoothing, but there's other input types that we have here as well. Again, this is right from the Unity documentation. So very common input methods. What we also did was we talked about rigid body when we were away, or in the last video, we talked about attaching a rigid body. And what a rigid body does is it adds gravity and physics to a game object. And from a basic physics perspective, what happens is we want to apply forces to push the game object and let the physics engine calculate the results, as opposed to us moving things manually from one position to the other. We could do it with positions, but it makes no sense to do it with positions if we have a physics engine that we're going to be using anyway for a platformer, which you need for things to fall and so on, right? And then, there's other ways of using the rigid body to detect non-physical motion and still do something with triggers. And there's a difference between triggers and colliders. One thing is there's a set of colliders that we're going to be talking about now. Typically, there's a box collider, and this is just the bounding box that surrounds a game object. So we can put anything inside the bounding box, even if it doesn't make any sense. We'll talk more about collision detection in another lesson. Or we can use a sphere collider or a capsule collider. These are the three, I would say, simple primitives that you can use to define your bounding area for your game objects. Okay, that's what they are. And we can also use something called a mesh collider, which you've also seen for the plane. And a mesh collider is something that's more processor intensive. And notice we actually used a mesh collider last week when we attached the tile object we made, right? And we also have something called triggers. So triggers, what they do is there's not a physical collision, but we can detect when there's an overlap. So there's no physical collision, but we can detect when something passes through something else, right? That's a trigger. So this is just some naming convention we're going to use. There's also something called collision callbacks, right? Collision callbacks are built in. So again, it's part of the application programming interface. So I'm not making these up. These are things that exist in Unity. And some of them are on collision enter, on collision stay, and on collision exit. They're events. Each of these event callbacks listen for a particular collision from an object. So we're going to use some of these as well. Similarly, there's also callbacks for triggers on trigger enter, on trigger stay, on trigger exit, and so on. Okay, so there's all the stuff that I really wanted to talk about today in the PowerPoint. But I'm going to show you now in Unity. Again, I'm going to go pull up Unity Hub. I'm going to kind of start with our lesson 2A. And it's going to load up lesson 2A for the second time. I'm just going to minimize everything we don't need here. Right, so there we go. We were left off the last recording with something that looked like this, where if I press my button, so here's the play view, this is the game view, and this is my editing view, my developer view. And notice if I press the cube, it kind of goes all over the place, like a wind is blowing it. Well, the reason why this is happening is there's a couple things that are happening. One is that I don't care if I'm grounded or not. I don't care if the cube was in the air, it would still move. Why? Because we're not limiting it in any way, right? We don't want the cube to move like this. We only want it to move when the object is grounded. So we want to be able to detect ground, right? That's the one thing we want to do. The other thing is we don't want it to spin the way it does, right? So if I move my cube to left and right, I mean, it's kind of like spinning like this because there's friction on the ground. There's a default friction amount. And the friction's causing my cube to turn and spin like this, right? So let's change that. Okay, so what I can do, and this is inside of Unity, not scripts, I can add a new material. So right now we have a material that adds color, But we can also add something called a physics material. So let's right click, and I'm going to create a new physics material. If you scroll down, you can see there's a physics material right there. Physics material is what it's called. Let's add that in, a physics material. Again, you could do it this way, a physics material like this, or you can click this and add a new physics material, and it's below where it says signal. All right, physics material. All right, so this physics material, let's rename this thing to ground. So I'm just clicking on it once. So if I click away, and if I click on it once and I hold it, it's going to say ground. You just rename it to ground. So this is my ground physics material. And on the right, you can see that it has a few properties built in without me doing anything. All right. One of them is something called static friction. Then there's something called dynamic friction. Then there's something called bounciness. All right. Okay. So who remembers from grade 11 or 12 physics, what is static friction compared to dynamic friction? Does anyone remember back in the day? First of all, anyone take physics that they can remember from? Well, let me remind you, right, if people can't answer. Static friction, uses a static friction coefficient. So that means when an object is not moving, it's on the ground, and if I push it, static friction is going to stop an object from moving, right? It's going to use its mass, and it's going to basically, the gravity is going to create something called a normal force that's up from the normal plane, from the plane, right? It's going to stop the object from moving. That's what static friction is. The higher the static friction, the more difficult it is for an object to start moving, right? Then there's something called dynamic friction. This happens when an object is already moving, right? And these can be different values. A good example of this is if I have rubber on concrete. If concrete was the basic ground, and if my object was made of rubber, then the force of static friction and also dynamic friction would be very high. It would be closer to 1. So this number goes from 0 to 1. It's a normalized value where this is 60% static friction to move object, which is a pretty sticky ground. All right. Let's reduce these numbers to 0.3. So make it more slippery ground. All right. 0.3. And let's increase the bounciness to like 0.1. Just a bit of bouncy, a bit bouncy. So bounciness, which is also called restitution, right, is when an object falls, it kind of has a tendency to bounce up a little bit, right? More realistic. What I can do is I take this ground material, and when I go back to my ground, here's my ground. Notice on the right, I have a material area where it says mesh collider. So mesh collider, I'm looking at my ground, I'm left clicking on my ground. On the right, there's a material area for a physics material. It's a different material than what we wrap around an object. It's a material for physics, and it's part of my collider. You can put the ground material or this kind of material to represent different kinds of surfaces, both on the player and on the ground. And if there's both friction, because again, I could have my object could be made of rubber, or it could be made of glass, as an example, or it could be that the ground is like ice and that this is made of plastic, and it'll be very, very like almost frictionless, right? But for now, we're going to leave my player alone, but we're going to change my ground. So I'm going to drag and drop my ground physics material onto my material area right here. So we've reduced it from the standard 0.6 and 0.6 to half the amount of friction. Now, if I run this again, you're going to notice that, well, I can slide around the ground more, and there's less tumbling, right? And there's more sliding too. If I let go, if I press some, if I kind of press some, if I add some force, right, to the right, you can see that it's going to keep sliding for a bit. Okay, you can see that that's happening as I press force, okay? So that is physics material. If I wanted to, if I go back to my ground, and if I want to make it really bouncy, just to check this out, if I go, let's say, from bounciness of 0.1, let's make it 0.5, so really bouncy, right? And if I was to run it now, you can see that it's going to bounce a bit. See that? See a little bounce? Let's try that again. Watch. So if I run it, I can bounce it a bit. By the way, you can always do it in real time. So right now, I'm in real time. I'm live. What I can do is anything I modify in the inspector while I'm live, gets reset when I stop the inspector. So I can change values around. So I can try and pull it up, and you can see now that it'll actually do it. I can pull it up higher. I can move it to the right. I can actually do it while I'm live, and it won't do anything. When I stop the inspector, it'll snap back to where it's supposed to be again. When I run it again, it'll be back to where it was before. So I can make some changes and test stuff out in the inspector, right, and try and see what it looks like. I can even change my properties live. So let's say, for example, I want a restitution or a bounciness of 1, really bouncy, like bouncing ball bouncy, right? And if I grab my player and I make that bounce, you can see now it's going to kind of bounce potentially forever, right? So let's go back and let's change my ground. My ground is 1 bounciness. And if I run it, you're going to see that's really bouncy now compared to before, right? Now I can make it even bouncier if I had a bouncy material on my player. My player is still like a bowling ball, right? It's not really bouncy. It's 0, right? Oh, my surface is really bouncy. But think about this as a mat that's like bouncing up and down. That doesn't make any sense. Let's put bounciness back to 0.1. So there's going to be a little bit of give, but not a great deal of give. All right. So again, now if you notice again, if I put it down to 0.1, it just stops. If I was going to fall from a higher height, though, you're going to see a bit of bounce. All right, so that solves my problem of slidiness. All right, that's slide it around. So I press it this way and I slide it around, you can see now that I can move right and left, right? No problem. Well, what about moving forward and back? Let's make that happen. And again, I'm just doing it here, and then we're going to actually do a better job than this in a few short minutes, because this is not great. This is just showing you how input works. I don't expect you to use this for your character controller at all. None of this, by the way. We're going to talk about other methodologies to do this. All right, so let's do, how about moving forward and back? Well, let's copy these. And instead of horizontal, let's use vertical. So the vertical axis is the W and S keys, or the full up and down arrows. And what I want to do is I want to change my vectors so that this is up, and that this is, or sorry, instead of up, sorry, not up. This is forward, and this is back. Up is actually up, like a jump. All right, so this is forward and back. All right, so left, right, and this is forward and back. I'm just annotating them with some comments here so you know what's happening. All right. All right, and if I was to do this and I made it go, so let's save it and go back to Unity. It's going to import my script and recompile. And if I run everything now I should be able to go not just left and right, but also forward and back. You can see that that goes there. And if I press both buttons at the same time, you can see that I can skate around the entire area and maybe even fall off. Again, let's show that again. So again, I can go forward and back, and then left and right. And I can see myself skating around. All right, so this is good and it's bad. It's going to skate a long time because of the way it's running. And I only want to move when I'm grounded. So what we can do is we can set up a Boolean to show when I'm grounded or not. Let's try this out. So on the player behavior, I can go to public and make a new Boolean. It's called bool, and I can call it is grounded. So is grounded is going to start off as false, right? And what I'm going to do by default is I'm going to say the only time I can move is if I'm is grounded. So here is a condition. I'm going to take all of these things and put them inside there. So if my object is grounded, then I can move. Otherwise, I can't. So I don't want to move in the air. That's not the kind of game I want to make, right? So now I shouldn't be able to move at all. If I did this if statement, because it's by default is going to stay false, right? Because right now it sets up false here. This is not going to move. I got to set up conditions so I can move. And for now, we're going to use colliders. Later on, we'll use something else. All right. So so again, if I move, if I make this go, now you're going to see that no matter what input I give it, I'm not getting any movement at all. I can't move my object at all, because if I look at my player, you can see that is grounded is false. It's off. Whenever you put a Boolean, you expose a Boolean on the inspector by using public like this bool, it gives you a checkbox. like this. But what about if I turn it on? So now I'm choosing grounded. Now, because I'm telling it it's grounded, I can move around. I should be able to move around again, right? Because I'm telling it that it's grounded, right? So here's ground. Now, because I turn, this on, I can move around again. And if I go back to my player and turn it off, then I can't move it around again. I don't want to do this by hand. I want to detect when I'm grounded. And the way to do that right now for the first iteration is if I'm colliding. All right. So what I can do in my player behavior is, this is a way of doing it. Not the greatest way, but we're going slow here to get you guys to understand how things work. I can make remember that public API we have, which is, there's a couple of callbacks. Again, on page 31 of the PowerPoint, I mentioned 3 different callbacks. On collision enter, this happens when 2 objects touch each other for the first time. There's some kind of contact, right? Then there's on collision stay, which happens while they're contacting. If it keeps connecting with something, then on collision stay will continue to fire, continue to trigger an event, right? And then on collision exit happens when 2 objects stop colliding, all right? So what I can do is, I don't need on collision enter, but I could use on collision stay and on collision exit. Let's try this out. So I can say something like void on collision stay. This is a weird way of doing it, but we're going to try it. And I can say that it takes type collision. This is part of the API. We're going to use other as the other thing that it's colliding with, right? And we're also going to have an event called on collision exit, which also takes a collision type, right? So those are the 2 events, on collision stay and on collision exit. Not the best way of doing it, but again, we're learning how the collision system works, right? And there's also on collision enter when it first touches. Let's use that too. Let's say, so where if you want to see all of them, these are all of them, on collision enter. I don't need them all, but this is how this would look. Okay, so these are all the 3 events that you can get with a collider. All right, now, in order for you to use these events, you must have a collider on your object. And we do. If you look back at Unity, you can see that the player itself has a box collider. If there's no box collider, my friends, there's no collision detection. Okay, we need some kind of collider. It doesn't have to be a box collider, it could be any collider. But we need a collider for there to be collision detection. A collider is just a bounding area. All right, so going back to code then, let's suppose that when I'm touching for the first time, I can change is grounded, right, to true. But this means that anything that I collide with is grounded as true. I want to check to see if I'm colliding with the ground only. So to do that, I can say if, right, other dot game object. So the other object that has a collider, the other game object, we want to say that we want to compare tag. Hey, there's that tag we created with ground. And if it's true, is this going to return compare tag is going to return a true or false. If the tag that's associated with the game object that this is colliding with, that the other collider is attached to, because there's 2 colliders happening, right? The collider that I have on my object, which is my player, and the other collider that I'm colliding with. It could be any other collider. I could have, I don't know, enemies that I'm colliding with, or clouds, or some other thing, right? So then I'm comparing the tag, which in Unity is right here, the tag of my ground, I'm comparing it for the first time, and I'm saying if my tag is the ground, then I want to do is grounded is true. As long as I'm still colliding, I'm just going to copy this, that's why I don't need these 2 things. As long as I'm still colliding with the ground, then I'm grounded. But if I'm not colliding with the ground, so if I'm leaving the ground, if I'm leaving it, then is grounded is false. I really don't need this one. I could probably get away with just using on stay and on exit, okay? but I'm not doing that just for illustration purposes. So notice that I'm always comparing the ground. So when I'm staying, I'm always staying on the ground. When I'm leaving the ground. When I'm on it, I enter the ground. So there's 3 states: enter, stay, and leave. And you don't need all of them. All right, so if I did this now, let's take a look. If I run it in Unity, if I go back, it's going to recompile for the next time. And if I run it, you're going to see that if I place on the player is grounded. Take a look by default, right? And I'm grounded because I'm on the ground. But if I fall off the ground, let's go to the edge. Watch. If I go to the edge and I fall off the edge, right? Watch what happens to grounded. Whoop, and I'm not grounded anymore. And now I can't move anymore, and it's going to keep falling forever. Let's try that again. So again, when I land, I'm not grounded, but when I land, boom, I'm grounded for the first time. And now that I'm grounded, I can move forward and back and all that stuff. So I need to detect that I'm always on the ground. That's what I need to do. Again, very simple collision detection and very simple ground detection right now. Not great. Okay. All right, great. So this is a way of me detecting if I'm on the ground. And if I'm on the ground, well, I want to be able to jump. The only way I can jump is if I'm on the ground. Okay, so let's do that part. And you're going to see I'm going to have problems with this part. So I'm going to say if input.getAxis raw, and let's use the axis called jump this time around. If that's greater than 0, so I'm jumping, if it's a positive number, I can also have a negative number to crouch as an example, right? But let's suppose I have a greater than 0. It's my jump button, which is the space bar. That's going to be my jump button. If it's greater than 0, then I can say that, this is jumping, I can say that rigid body.add force, and what I want to do is I want to say vector 3.up, I want to go in the up direction this time, by some kind of jump force. I don't have jump force, but I'm going to put it in here. So I don't have jump force yet. I haven't defined that. And I want jump force to be different than movement force, because jump force usually is more because I have to escape gravity. So let's go back up to the top, and where I have a float for movement force, let's add a public float for jump force. So again, I have a public float for jump force, and I add the public, I multiply jump force by my vector 3 up. Again, let me show you the code. And just to make it easier, I'm just going to collapse these areas so you can see the code, the new code. So you can do that, right? So here's what it looks like. And I don't need to start right now. So here's my jump force, and I basically added a jump. And the only way this is going to be able to jump is if I'm grounded. If I'm grounded, then I want to be able to jump. If I'm not grounded, I'm never going to be able to jump. Okay, let's try it out, and then I'll go back and ask you if you're with me. All right, so we're recompiling. You can see that if I press play now, well, first of all, I need to put in a value in jump force. Let's put a value of 10 for now, like double, and see what that does for me. And if I press play, and if I press the space bar when I'm on the ground, then I just jump a little bit. And if I hold it, it's just going to keep jumping like that. And then it's going to rock away like this and do its little dance around as long as I hold it. Why? And why is it flipping over like that? Well, you got to think what's happening here. I have a little bit of bounciness and a little bit of static friction and a little bit of dynamic friction. And what's happening is when I jump, it's trying to be realistic. And so I'm getting a jump force in the middle of my game object. And when it lands, it's going to hit friction. And when it hits friction, it's going to shift a little bit. And depending on how far it falls, there's going to be more of shifting and bouncing. And it's going to kind of move all over the place, right? So again, if I move it now, everything is still good. It still slides. But if I jump while I'm moving, well, then I'm going to tumble. Like so. Woo, right? Tumble. And that's not good. So, and let's put a little bit more force. Instead of jump force being 15, let's make a jump force of 20. All right, so if we did that, and if I land, so that's like a lot of jump force. So now you can see that it's much more. I can jump a lot higher. But I kind of tend to float, right? That's a pretty floaty jump force that I got going on, guys. Look at, and it's going to just flip over, and I can press the buttons while I can move while I do stuff, and I'm going to tumble all around again. I can press the space bar, hold the space bar while you're moving, and you can jump and jump and jump and jump, right, until you fall off the screen, and I can fall off forever. By the way, one thing to note is there's this information here in transform, but if you look at info in rigid body, the rigid body info will show you what's really happening in terms of my physics. Take a look at that. So it kind of turns it on, and it kind of comes to rest. It's awake, and then it becomes asleep. It's awake, and then it becomes asleep. And it tells you when it sleeps, then it stops velocity and acceleration and everything else. Okay, so that's kind of our first foray into moving around. Not great. And then we can go further than this and keep on adding things. But I want to add a controller that actually does something, right? So for this, there's some built-in things that we can do from the get-go to make our controller work. So I know you're going to get mad at me, but we're going to start a little bit from scratch. I've just wanted to get some input. I wanted to get input from you guys, or input for you guys, so you can see how things you get input and what the effects of the input is, right? But now we want to modify this so that you can actually come away with an actual working controller that is a first-person perspective controller that allows you to use your mouse to look around from scratch. By the way, you can always download an asset too, with some script built into it. But instead of doing that, I want to discuss it because there's a lot of learning here. Everything from how to put a script together on an object, to how to do physics, to how to do a lot of stuff. All right. So what I want to do is I want to kill the player. Kill him. Goodbye, player. Delete. All right. So don't worry. The scripts are still there. Here's the scripts, camera controller and player behavior. But the player object is no more. All right. And I'm starting from scratch because there's a lot of work we have to do in terms of how I want my player to move. So first of all, let's add a new object. So again, this time I'm going to go to the plus, and I'm going to add a brand new empty object. Empty. There's nothing on it at all. Okay. And what I want to do with the empty object is rename this to player, right? Here's my player. And let's reset the player. So my empty is where it is right now. Let's reset it so it's at 0, 0, 0. And what I want to do with this, there's something called a controller, a character controller that you can add in right away. So if I go to add component, Unity makes it a little easier for us in some ways. And if I type in character, there's something called a character controller. Let's add that in. Notice that if I zoom in, I'm just going to get rid of this. I'm going to reposition my screens here so we can see it in a little bit bigger. If I zoom in here, what it does is when I just have a transform that's empty, so I got a player that's empty, and I got my character controller in here, notice that I've got a little half of a capsule. And this is hidden in the background. This is part of the script, the component that makes up the character controller, guys. Okay? So that's something to note, that the character controller is right in here. What I want to do is I want to get this thing kind of position up. Let's move this thing so you can see the whole capsule. This is what the capsule looks like. All right. And again, the reason why the capsule is showing up is because I'm clicking on player and I've added a character controller. It's an empty game object. Let's tag this thing as a player. Let's do that. So we're tagging it as a player. And we'll save the scene. So let's do that in, by the way, if you did this in play mode, you see I didn't lose anything. So I can do it all again. So I delete the cube. I add a brand new empty object. We'll call this empty object player. I'll reposition everything so that it is, that was my mistake, in the 0, 0, 0 position. As an example, I can add a component, a character controller. There it is. And if I double click on the player in my scene, you can see that it's here, right? And I want to move it up just a little bit, so kind of up to here. Notice when I do that, you can see that the total positioning is like 1.045. Let's move it a bit above the ground so you can see that it's here hovering. Right, let's say at 1.5 above the ground, right? And you can see that I've got my little capsule that's right here, all right? The height of the capsule is 2. And my radius, how fat the capsule is 0.5. All right, so that is my player controller itself, okay? And what I can do with the capsule is I can make it a little fatter. Let's say make it 0.6, so it's a little bit fatter around if I want to, or leaner. If I left the 0.5, or taller. If I made it like 4, it could be much taller. Here's my capsule. So this is the height and the radius. I don't need that. I want to make it 2. 2 means 2 meters tall. That's what it means, 2 meters tall. All right, so that's what this little character control is. It also has slope control, so I can go up slopes and stairs and a bunch of other stuff. All right, so now we need a bunch of things for me to make this go, okay? And I'm gonna do the script a lot different than what I had before. So let's add the player behavior script on top of it. Just gonna drag and drop the player script, except the player script is gonna change a whole pile. Let's do that now. So, and the other thing I wanna do is I want to connect my camera. My camera right now is an object that is like way over here. And I want my camera to be associated with my player. It's going to be inside of my player's head, if you will, right? So in order for me to do that, I'm going to drag my main camera onto the player object like so. And I want to reset my camera. So I'm going to go back to where it says up here in the transform. I'm going to kind of reset my camera so that it's inside the player. So here's the player. And you're going to see that the camera is kind of in here. So the main camera is underneath the player. It's almost like a child of the player object. I want to grab the camera and I want to move it, not the whole player, but the camera object. And I want to move this camera object higher up. So you can see that right now, it's kind of at the almost the head of the player. There's my camera. I'm going to move it a little higher. And I'll give you the numbers so you can see what yours is like mine. So again, if you look at the camera, it's kind of at the head area of the capsule, right? So again, just moving the camera up a little bit. In order for us to visualize this, let's add a body. All right, so here's the head, and let's add a body. So I'm going to add another body to the player. Okay, so just to add a body to the player, just so that we can see it move around. Okay, so I want to right click and I want to add, right? I want to add some kind of collider. Let's add in another 3D object and we'll make it a capsule. All right, so here's a capsule. Notice that it hugs exactly the way it looks, but this is not going to be great from collision detection perspective. I don't want it to be colliding like this. So let's, instead of adding a capsule, let's add a 3D object that is a cylinder. So cylinder, notice that it is actually longer than this bottom part. And we can make this cylinder so that it is the same size as my body. All right, and not the bottom part. The bottom part here that you see is going to be something that hugs the body. Actually, we can leave it as is. It's fine too. One thing we want to get rid of is the collider. We don't want a capsule. We don't want a cylinder collider. We don't want a capsule collider on the cylinder, right? We don't, because we already have a collider on the player because of the character controller. That means we'll have 2, and I don't want that. So we can go to the cylinder that I added and get rid of the object. Let's get rid of it. All right, so there's no collider on the cylinder. It's just for visual purposes. Let's add the material that we had before, the mesh renderer. We had a material which we used. So we can go to materials and grab that green material and drag and drop it into the cylinder so we can see what the cylinder looks like. So again, what you're seeing is at the head is where the camera is. If I look at the camera now, we can actually visualize it a little bit better. We want it just to slightly stick out of the head like this. So kind of at the top. Okay, so that's the camera sticking out of the head a little bit. All right, that's what it looks like. All right. And what we want is we want to be able to have a ground check at the bottom, which is going to be just an empty game object that's going to check with the bottom of the cylinder that I'm grounded or not. Okay. That's what this is going to do. So how do I do that? Let's go to the player again, and we're going to right click, and we're going to add an empty 3D object. Here's our empty 3D object. It's called game object, but let's rename this thing to ground check. Ground check. By the way, this thing I'm going to show you is a classic way of doing it, but you can do it other ways. Now, notice what we're seeing is we're seeing a perspective. So the whole camera angle we're seeing is a perspective. If I click, it's kind of hard to see, but it's underneath this gizmo. there's a little thing that says perspective. If I click on this perspective, it becomes orthographic. And I can look at the camera, or I can look at the object like this. And so what I've done is, notice it says right. I can click on this thing to make it go from perspective to orthographic. Orthographic means it's flat on, right? And I've clicked on these values. You can actually click. I clicked on the x-axis so I can see from the right. If I clicked on the z-axis now, I see it from the front. X-axis goes from the right. I can flip to one side or the other. So this is the right side of the object. So you see the camera is facing forward. This is forward. What I want to do is I want to take that ground check and I want to lower it, just the ground check. I want to just use the little gizmo here to lower it to the bottom. And if you notice, if I lower it to the bottom, then it becomes something like -1. So let's just change it to -1. So again, ground check, it's an empty game object, 0, -1, 0. Cylinder is just a representation of our character, which we're going to turn off later. We're just literally can turn off the mesh renderer. We don't have to see it. It's just for us to help us debug, right? Main camera is the main camera that we put into the head, and I put it at 0.9. Let's make it so it's even. So we'll say it's like, if I put it at 1, that might be good. So 1 is where the camera is, at 1. Okay, notice it's kind of half in and half out of the actual object. Okay, it's at 1. So the camera is at 0, 1, 0. The cylinder is at 0, 0, 0. The ground check is at 0, -1, 0. Those are the three things we have. Okay, and that's the player object. In the player object, we've added the player behavior. Okay, are you with me? Check mark if you're with me with these changes. X if you're way behind me, you don't know what I'm doing. So what I'm doing is I'm creating a character controller where the camera is inside of my head so I can use it as a mouse look. So I can look up and down with my mouse and do all this other stuff. All right. And I think I'm gonna have to make a video offline for you guys after this. I'll keep going. After your time is done with me at 6:30, I'm gonna keep going. I'll make another video for the assignment details that you're gonna get. And I'm gonna make probably another half an hour or so after that. You don't have to stay with me after 6:30. I'm gonna keep going though, because I wanna make sure you have everything you need for this week, okay? All right, so, and then you can watch it later. All right, so here is the object. I wanna go back to perspective view. So I've got the object now back into perspective view. And again, you can use the same thing to move around the object just like before. It doesn't matter. But the reason why I did this, I wanted to put the object together. All right, on the main camera, my main camera has a skybox. It looks at, we'll talk about cameras another day. But I want to add a component. We made that script before, but we never did anything with it. Let's take that camera controller and attach it to the camera. So now there's a camera controller that doesn't do anything. It's empty script. It's attached to the camera. And we also have the player behavior that's attached to the player itself up here. Okay. Pretty good. All right. And what we want to do at this point is I want to start. Let's start by looking at the camera controller. So what I want to do is with the camera controller is when I move my mouse left and right, I want the actual camera to rotate, not necessarily the player, but the camera is going to rotate left and right, and the player is going to follow suit. Its object is going to rotate left and right as well. Okay, but the camera sitting inside here. Right? I also have a cylinder that's here. This is the actual body. Let's rename this to body. So my body of my character is here, right? Here's my main camera, right? And here's my ground check. I haven't done anything with the ground check yet. All right, let's add some code to the camera controller for the first time. So double click on the camera controller, and in the camera controller, it's going to be slightly different than what we've done so far. But let me explain what is happening as we make this little script. It's not a big script, but we're going to start off with a couple things. So first, what I want to move my camera around like as if it's my head, right? And what I want is I want to, in here, have a public float. I want to call this like mouse sensitivity. Okay, and I'm going to set this by default to like 1000. Okay, something crazy, big, a very sensitive mouse. I also want a public transform, right? That's going to transform the player's body. So player body. And I want to get a reference to the player body from my camera. Okay. In the update function, I want to create a couple of variables. I'm going to call this a local variable called mouse x that I'm going to calculate every frame. It's going to be input.getAxis, not getAxis raw this time, but getAxis, which is going to be a scaled, smoother axis. I'm going to look at the mouse x axis, and I'm going to multiply the mouse x axis by mouse sensitivity. And then I'm going to multiply that by time.delta time. So whenever I do anything multiplied by time.delta time, it takes the difference between frames. So let's say, for example, I go from frame 1 to frame 2. Remember, this update function is called every frame. So what's going to happen is it's going to say, okay, what's the difference between frames? I want to multiply that difference by the mouse sensitivity so we can have a lower value. So instead of it spamming, whenever I kind of click my key a lot of times, if I click the mouse X, I don't want it to spam. And so what time.delta time does is it scales it according to the time that is being, the game time. That's what it's doing. It's scaling it according to game time. We only do scaling in the update method. We don't do it in fixed update. All right, next, I want to do the same thing. So instead of just mouse X, I also want to get input from my mouse Y, or we'll call it mouse Z in this case, right? So there's mouse X and mouse Y. You can also call it mouse X and mouse Z. Here, we'll just make it mouse Y for us. And we're still going to get axis from the Y. So now we have input from the mouse X and mouse Y, but we're saving it here. We're not doing anything with it yet. Okay. Now what I want to do is I want to make a new float, private float, and I want to call this the rotation on the x-axis. We'll call this x rotation, and that's going to be equal to 0.0f. All right, starting off. So at the beginning, it starts off at 0. There's no rotation. And what I'm going to do is I'm going to calculate the rotation down here. So I'm going to say x rotation. So the rotation on the x-axis is minus equal to the mouse y. Now, why minus equal? Because I found that if you did plus equal, then your rotation is actually going to be reversed, right? And what I want to do is I want to clamp my rotation. We're going to talk about this later on, but I want to clamp my rotation on the x-axis so that it doesn't go further than 90 degrees to the left and 90 degrees to the right. Right? I don't want it to look in too far away. So the way it works is x rotation, right? And I want to say is equal to math.clamp. It's a mathematical function that's built in. Mathf is built into Unity. Here's mathf.clamp. And what we want to clamp, we put the value we want to clamp first. I want to clamp the x rotation from minus 90 degrees to 90 degrees. So I'm clamping it in a range. And let's put the 0 zeros. We don't have to, but I want to put the 0 zeros in here. So this is the rotation of the mouse. And then what we're going to do is I want to use the transform.local rotation of my object to say that I want to use a quaternion. And again, I want to use a quaternion Euler rotation of the x rotation as well as 0.0f and 0.0f. So quaternion allows me to avoid gimbal lock, right? That's what it does. I'm using Euler angles to rotate around my object, right? And I'm rotating across the x-axis in this case, right? So that's what I'm doing. Don't worry if you've lost me. Just follow me here. I'm giving you the code, right? And then I want to have, when I get access to the player body, I want to rotate the player body, right, from a vector 3 up perspective. So that's where I want to rotate around. I want to rotate around the Z or the Y axis. That's what I'm rotating, multiplied by my mouse.x. And that is your mouse look code right here. This is mouse look. So what happens is if I move my mouse around now, I'll be able to look up, look down, look left, look right with this mouse look code. Later on, when we convert this game into a mobile game, we'll have a different scheme to look up and down and so on. All right, let's test this thing and see if it works at all. So I'm going to go back to Unity. And what I need to do to make this work, if I don't do this, is if I look at the main camera, it's looking for a player body. And what I need to do is go to the body and drag and drop it. So the player body is going to rotate. If I didn't do this, then I wouldn't have access to the player body. The player body is this thing that I made. Let's see if I'm right. Maybe I'm wrong, right? So how does this work? Well, now what we can see is if I look up and down, I can move my mouse up and down. But the problem is that, notice my mouse is hanging out here. I move to left and right. I can't really tell that I'm turning my mouse left and right because, again, I'm not really seeing the changes. Let's take a look at the camera. And if you look at the camera script here, right, all I see is mouse sensitivity is 1000 and player body. So if I click over here, again, you can't really see much left and right, right? You don't know if you're moving left and right. Let's put something so you can tell. I'm just going to split screen again so you can see the difference. I'm going to go move this to the right, and then we can see what happens when I do this to left. If I press play, and now if I look to left and right, you can see if I'm actually rotating or not. And you can't see it because it's of what's happening here. But what you're going to see is what I want is for the camera object. So if we click on the camera that's in the scene, this camera right here, we want to be able to see what it's looking for. We can definitely see that it's looking up and down. Okay, we can see that the camera is shifting up and down, even though my object is not moving anywhere. All right. So what to do? Let's add another object in the scene so we can differentiate between the horizon, because we can't really tell there's anything inside the screen because we're in the dead middle and it looks like we're not moving. Let's just add another cube somewhere. So again, I'm going to right click and I'm going to add a 3D object, a cube, and we're going to just put it way over here and somewhere in the scene. Let's just reset it and then I'll move it. So reset, it's in the middle. I'll move it to in front of me as an example, and I'll move it up. So I'll move it, let's say at Z, I don't know, we'll put it at 20. And my position will be 0.5 up so we can see it. So there's just as an anchor so we can see what we're looking at. Let's see now if we can change directions when we're looking. All right. So let's try this again. I'm going to run it. And what I should be able to do is when I look, then I should be able to move to the left and right. And notice that it's not rotating. My camera is, even though I'm trying to make it work, right, it rotates up and down, but I'm not being able to rotate right and left. It's not moving my object at all in any way. See that? Okay. Let's fix this thing and let's make sure that I haven't made a mistake. So again, player body is what I got a reference on. So there's my camera. Here's my player body, right? And let's take a look at what if I made, instead of my player body being this, what if I made my player body this, my player, right? So that kind of moved my entire player around, not just my body. My body would just rotate on itself. So let's see if that's the problem. So if I go to main camera, and instead of dragging and dropping my body, what if I drag and drop my player on there like this? So it says player transform. Now if I run it, and if I look around, now you can see that it's moving. And now I have a free mouse look. I move around and I can see that indeed my camera is looking up and down. You can see that here in the scene, I'm looking at my box, but if I look around, I can move it. I'm looking at it in different angles. So that is the player look script. And again, the way I did it was I have my main camera, I've attached the player look script onto it, and I've dragged and dropped the player, not the body, but the player itself onto them. The script doesn't inherit a native class that can manage a script. Yeah, you have to make sure that it has mono behavior up here. So your camera controller has to have mono behavior. And somehow if you mistyped or something, and then it'll It won't be mono behavior. Let me do one thing here. So in my start method, I'm going to change the cursor. I don't want my cursor. That's pretty funny, but my cursor is bugging me. So I'm going to say cursor.lockState is equal to cursor lock mode locked, right? And what this does is when I'm running my game, I won't see my cursor. It'll be invisible. So again, it's not perfect what we're doing here, but it's better. And if I run the game, I'll come back to your problem in a sec. If I run the game now, you can see that once I click inside there, I can't see my cursor anymore. And just like normal, I won't be able to see my cursor. Okay, so that's what this does. All right, so that is my camera look functionality. Let's save this and put it up on GitHub so you have it. I know we're going to run really right to the last moment here, guys, today. So I'm just going to close this down. I'm going to save my script, save my scene, which is important. And then I'm going to go to here where it says my Gitkraken. I'm going to see I have 5 changes. I'm going to add to changes. I'm going to say added camera controller. And you should have what I have now. After I have my camera controller, I'm going to commit those 5 changes and push it up to GitHub. So you should have what I have now at this point. All right, so take a look. If your script doesn't look like mine, then check your script first, and then you know how your associations work. Okay, so that's next. I'm going to load Unity again. So I'm going to go back to Unity Hub now that I put it up on GitHub, and I'm going to load this up again. So I'm going to reload Unity. Remember, I closed Unity down to put it up on GitHub, and then I reopen Unity again. It's a safe way of doing things, guys. Then you won't have as much corruption. Cool. So now let's fix the player behavior, because the player behavior is all messed up because it's working with physics. But I want to use this thing called the character controller, which is built into Unity. I don't have to download anything, and this is all useless. So let's rejig this thing. One thing is my player does not have a rigid body, so I won't need this built in here. I'm going to use my character controller built in. So let's go back to my player behavior now. So we had a lot of code for my player behavior, but it was all prep code to show you how things work. I'm still going to have a bool that is grounded. I'm still going to have that. Instead of movement force and jump force, that's going to be gone. So let's get rid of those. So I don't need that. And let's just wipe out pretty much everything we have. So let's grab all this. And we're not going to use collision detection for our ground detection. We're going to use something else, which is a way neater way of doing it. Again, by the way, this is a classic example. Some of this is not my code. Some of this is from other places, but I've been using something like this for a while. When I make my first, when I made my first controller back in the day, and again, I modified it over time. But this is something that you can change. You can use, and don't feel free about using the code. It's just, again, it's in the public domain. It's not mine necessarily. Okay. The next part is what I want to do is I don't need a rigid body, so I don't need that. But I do need is grounded. That's important. And I want to get some references. So the first part is I want to get a reference to my character controller. So I'm going to say that public character controller. You can see that I get a reference to that. I'm going to call it controller, right? And if I save the script and I go back out to Unity, so again, going back to Unity, if I save the script and if I look at my player object, then I have this character controller. What I'm really looking for is this character controller right here. So just like I did last time, I'm going to go back to my script here. And in my start function, I'm going to say that, hey, start, let's get a reference to the character controller. So I'm going to say controller is equal to get component character controller. Okay, get component character controller. And if I was to run this thing the way it is, right? So let's go back. And if I run it, again, it doesn't move now because I've taken the movement script away. But take a look at that character controller. If I press play, then I should get a reference, which is what I do, right? So notice here, I get a reference to my player controller right here. And that's kind of important, isn't it? That I want to get a reference to this, right? So that's what's happening to it. So I instead of me dragging and dropping manually here, I found it. Okay. By the way, I finally got my gizmos back. I had to restart Unity for that. So I was worried. I was like, wait, how come I'm not seeing my camera move around? Well, my Unity sometimes needs to turn back on again. All right, next, I want a speed. I want a speed. And my speed is going to be something that I'm going to move around with, right? So one thing that I want is I want to be able to move my controller with some kind of movement speed, like a max speed, if you will. All right. So let's make another public property. And we're going to make it a float. We're going to call this max speed. My max speed, I'm going to set to something like, by default, like something like 12. All right. We can make it other, but let's make it 10. So it's more accurate, like more like kind of a lower speed for now. We can change that later. I'm also going to describe my gravity. So public float, I want to have my own gravity. I don't want to use a rigid body in this case. And the problem with a rigid body is it adds the exact gravity, so like 9.8 meters per second, to an object. Here, I want to be able to set my gravity to much higher because I don't want it to float like it was doing. So let's make it so it's a rigid, so it's my default gravity is going to be like 30. And you're going to be like, wait, 30, that's not right. That's our gravity is 9.8 meters per second squared. You're right, but not for games. For games, we need a quick fall when it comes to gravity, right? Also, what I want to do is pre-calculate my jump height. So I'm going to say public float, and we're going to say a jump height, right, of something like, let's say 3 meters. Okay, that's what this is. We're going to pre-calculate my jump height, right? I also want to get a reference to a public transform, which is my ground check. Ground check. This one we're going to have to drag and drop. Transform. So transform is, remember what a transform is? It's position, rotation, and scale, right? So let's go back. We haven't done much. Let's go back to Unity and see what this looks like. So back to Unity. And if you look at my my player, I have a public check called ground check. Well, here's my ground check. Remember I put it inside of my player object? Here's my ground check right here. So I'm going to just drag and drop that ground check in there. So I have a reference to the ground check. That's going to be the bottom of my character, right? That's what I want to use for ground check, okay? Notice my gravity came in here automatically. Anything I put here appears here by default, all right, in my Unity script. Let's keep going. I'm also going to have a radius, right? So like basically a ground radius. So let's try this out. So I'm going to say public, and it's going to be a float. We're going to call it almost like the distance between my object and the ground. So we can call this we'll call it the ground radius. All right, and we're going to set the ground radius by default to something like 0.5. Again, we may have to modify this later on. Okay. I'm also going to use something called a layer mask, and this is something new as well. So public layer mask, it's built into Unity, and what a layer mask is, and this is the the ground mask. All right. What a layer mask does is it allows you to select what object you want to collide with when we use physics. So if I go back to Unity now, right, and if I look at the player, you can see now that I have this pull down for ground mask, and I can select my ground. How did I get my ground? Because I made a layer. Remember in the beginning, I made a layer called ground, right? I want to tag the object as a player, by the way, too. So this whole thing is a player object, and then my layer is ground. The problem with doing this is I really can't see my radius in the bottom of my player. I can't see what this looks like. It's going to be like a round area underneath my player where it's going to detect the distance between my player and the ground. Okay? So what I want is wherever my ground object is, my ground check, that is the place where it's going to draw. And what I can do is I can use on gizmos, the gizmos that's built into Unity, to draw a debug gizmo for myself right here. So to do that, I need another lifecycle function. So I'm going to call this void on gizmos draw, or on draw gizmos. I can't remember what it is now. Actually, it's in our PowerPoint slides. In our PowerPoint slides, we talked about this way over here. We have on draw gizmos. That's what it's called, on draw gizmos. It is a function that runs basically. So when I want to draw a gizmo, I can say the gizmos dot gizmos dot color. I can set the color to a color dot green for debugging color, or color dot white, which is what I want to do to match up my gizmo. So this is the gizmo color. And then what I can do is I can gizmos dot draw wire sphere. So I'll draw a sphere in the editor that's has a center and a radius. Well, guess what? I have a center, my ground check, and I have a radius, my ground radius. So my ground check dot position, and my radius is my ground radius. So that is what I'm going to be drawing. So this is on draw gizmos. On draw gizmos triggers in the editor only, so that I can visualize what it looks like in Unity, like here. And notice what I'm going to get is a nice little area that's drawn. So this is how it's going to start detecting my collision detection. It's going to detect it from the bottom, from right back at the bottom of my object. And I'm drawing the gizmo like this through on draw gizmos. That's what's happening here. Okay, I know I'm giving you a lot, but this is we're gonna get used to it, because there's a lot to give you if I want to get this going. And guys, we're sitting at 6:21. If you have to go, I'm going to keep recording until we're done, just the movement, and then I'm going to stop recording. I'm going to talk about the assignment 1 part 2, as well as do the Blender part, and you can watch that later if you want. Okay, I'm going to keep going though, because I want to make sure you have everything you need to be successful this week. All right, next, now that I've got some stuff set up here, my ground mask and so on, I need a couple things. I need a thing to keep track of my velocity. So this is kind of like my velocity for gravity. So it's going to be a new vector3 object. Let's make it public, not private. I'm making everything public just so you can see it all. And later on, next week, we'll do some privates too. We'll make it so it's called velocity. All right, so public, and all this is going to be exposed in the inspector. So if I look at the inspector, you can see now that I have all those things. The ground, here's my velocity, which is an XYZ vector3 object, and a bunch of stuff. This is all prep, by the way. I want to set my velocity by default on the y-axis. We're going to set it so that it is already falling at -2. So I'm going to start off, instead of my velocity incrementing from 0, I'm going to say that my velocity on the y-axis is going to start already falling when I'm doing gravity at -2. So that seems to work better. Inside of my update also, maybe I shouldn't do that here in my start. I'm just thinking about this again. Let's do it on update. So on update, how do I check to see if I'm grounded or not? This is interesting. Let's do that part first. I'm going to say is grounded, and this is a different way of calculating. I'm going to do a sphere cast, which is kind of neat. Sphere cast is like a ray cast, but I'm going to ray cast in a sphere area, right? As opposed to doing physics detection or collision detection with physics, with colliders. I'm going to use physics for this. I'm going to say physics. I want you to detect in a, I can check box or check capsule or check sphere. This is like a sphere cast, kind of. I'm going to check a sphere, and I'm going to start with the ground check position. And I also want to say I want to check with the ground radius, and then the ground mask as the 3 things. So that's what it takes. That's why I made those things up here, right? So ground position is where it starts. How far? Ground radius, that's the sphere radius. And ground mask, what am I colliding with? And it's going to tell me if I'm grounded or not. Let's take a look and see if I just do this, what I do now. So again, if I run it, by default, it's not grounded. And if I press play, it's going to still stay not grounded, right? Because it's not colliding right now. It's off the ground, right? All right, so that's how I'm going to detect the ground, if I'm grounded or not. And what I'm going to say is, if to check to see if what happens if I'm grounded, right? And my velocity on the y-axis is less than 0, then what I'm going to say is I'm going to keep bringing my velocity down, where my velocity dot y is equal to -2. This is where the -2 comes in. So this is kind of like me bringing my object to the ground. That's what's going to happen. Because remember, I have that little buffer underneath here. I have this little buffer here. I want to bring this whole thing right to the ground. And so I'm going to reduce it by -2 to do I'm going to kind of drop it right to the ground so it connects. All right, so that's what the isGrounded does. I'm going to set up my float x, which is equal to this is my inputs now. My input.getAxis. Not get axis raw, but get axis, which is scaled. And that is horizontal. So I'm getting input from there and storing it minus -1 to 1 inside of my x-axis. And then what I can do is I can get float z, not my y, but my z-axis, because I'm on the xz plane. Notice I'm here on the, this is the z-axis and this is the x-axis. So I'm on the xz plane. The y-axis goes up and down. So z then is equal to input.getAxis vertical. Okay. And then what I'm going to do for the first time, we'll start off like this. We'll say that, hey, controller, remember that built-in controller of unities? I want you to move. Well, where do I want it to move? I want it to move some distance. That's how we're going to move my object, right? But I need to set up a vector3 to do that. So I'm going to make a local vector3. I'm going to call it move, and it's going to be equal to transform.right. So I'm move to the right, some distance multiplied by my x-axis. So if my x gives me positive numbers, I'm going to move to the right. If my x is negative, so if I scale to the left, if I press the S button, this will be negative, and it'll multiply against the right vector and invert it. So it'll go to the left, right? So I only need one. And then plus my transform dot forward, right? Multiplied by z. So wherever I'm looking, wherever my object is looking, which is straightforward, I'm going to modify the way it looks. When I move my mouse to the left and right, wherever I'm looking is the direction that I'm going to go forward. Okay, that's how that works. And then I'm going to take my move and multiply it by my speed. And I'm going to multiply it by time.delta time to scale it, because otherwise it'll be too crazy, right? I'm not going to make gravity work yet, okay? But let's see how this works. If I can press buttons and if it'll move it all, right? All right, so let's try this out. So again, I'm going to scale it, and if I press play, and if I press the, again, some buttons, you can see now that I can move around. So if I look in this direction, let's say if I look inside the direction of this, I can move closer to this thing. And I've got a first person controller. Look at that. So I can move around. I can't jump yet. I want to be able to jump, but I want to be able to move towards wherever I'm looking. So if I look towards my cube, I can move towards it, and I can look around. So I've kind of a mission accomplished right now, but I want to improve, kind of increment or use gravity, and I want to be able to jump as well. So in order for me to make gravity work, before I jump, let's do the gravity part. I want to say that velocity.y, I want to increment my velocity, is equal to a mathf, right, dot square root, actually, sorry, let's do that again, plus equals to my gravity, whatever that is, minus 30, times time.delta time. So here I have a first move. This move here, it moves me around. This move here moves me up and down. And this is going to make it so that I'm going to do another controller.move, and I'm going to take this time the velocity that I'm going to get, which is the linear velocity on the y-axis, and multiply it by time.delta time again. Why am I multiplying by time.delta time again? Because remember that whenever I do any kind of physics calculations, it's t squared. It's the default formula, and I'll put this up the top of my head here, is initial position plus velocity times time, right? Plus 1/2 of acceleration due to gravity squared times time squared, right? So this is time squared. I'm multiplying it by time first, and then I'm multiplying it by time again. All right, so that's how that works. And now that I have that, I should have gravity. It should take hold. I should fall. All right, so let's see if that works. So again, going back to this, and if I press play, I should fall to the ground now. So yeah, let's see that. So now I'm on the ground, and you can see I can look around now, and I can look for that cube, and then I can march towards that cube. So I can, let's say, march towards the cube, right, as I go closer, and I can skip around, right? And I get the same kind of motion as I have. You can see that the object moves around kind of on the ground, just like normal. Okay, and then I can, when I look around, my camera moves around, but not my entire body, which is kind of cool. So that's what the character controller does. The character controller takes care of a rigid body for us as well as a collider. That's why it's built into Unity. It's a great little thing. It's not a bad way of doing it. There's some really great controllers that you can download from the internet as well, instead of you using one that I'm making with you. But I'm showing you the code for how to make it work so it's not too janky, and it works for most of the things that we're going to be doing this semester. So once we've done this, we're paying the price for it up front, and then later we're going to use this for the entire semester pretty much, because we're going to build on this. Okay, but what about jumping? So jumping has to come before my velocity, my gravity comes into play. And I'm going to say something like this. If my input dot, again, get button down is something we can use, jump. If I'm getting my jump, as an example, my jump button, and I'm already grounded, this is one way of doing it. We can modify this later on. Then my velocity on the y-axis is equal to, remember, we're going to make that math calculation that basically calculates how much gravity or how much force we need in order for me to jump a certain height. This is the other way around. Instead of saying, I want to add force and it's going to take me wherever it's going to take me, I want to guarantee how high I'm going to jump. So I can do that by using a mathf dot square root, and I want to calculate the jump height, and I'm going to multiply it by a negative 2.0 and by gravity, and multiply that by gravity. And once I've done, this is actually a physics equation that's in play. And this little physics equation calculates the amount of force that I need on the amount of velocity I need on the y-axis to move, to jump up 3 meters. And you can decide that jump height, whatever it is. All right, this should do it. Let's see what I get. And I should be able to jump around now. And I should have a full character controller at this point. So let's take a look. So again, if I run it, and you can see on the right that I'm grounded. I'm going to get rid of a couple things in a second. And if I move around, so let's say I move around my thing, and if I jump, you can see I'm going to jump up, and I can move, and I can jump, and I can move, and I can jump on that. I'm probably going to jump on that cube, right, if I want to. I can also try and push the cube because I have a rigid body, and if I made that cube have a rigid body, I can actually push that cube around, right? One thing to note is, do I really care to see my capsule like running around like this? This doesn't make sense, right? And it's really kind of gives me a little bit of vertigo. So let's turn that off. So what you can do is remember that this is a debug. This is something that we're using for debugging purposes, so we can see our character. But remember, from a first-person perspective, we're never going to see our own body, right? So we can just turn this off. And the way to do that is if I go to my body, and I can go to my mesh render and just click it off like this. By the way, if you'd like to see your mesh renderer in wireframe format, you can certainly add a gizmo for this. I can add a gizmo that draws my cylinder, or if you want to, or a capsule. It's totally up to you, right? But for now, I want to turn this off. And if I turn it off, there's no shadows. So I can actually, even when this is off, so is all this, right? So if I run it now, you're going to see that I have no shadows, and it kind of makes it so, I just see my plane, and if I look down, I don't see anything, and I see my cube, and I don't see anything that's around there, right? So that's kind of what it looks like. And so this is character controller done, all right? Let's move this back into here, and let me show you what that looks like in the game while I maximize everything. It's not perfect because there's a few things that are still janky about it, all right? For example, my mouse, it starts off kind of looking at the ground, which is not cool. And there's a bunch of other things we can change later on, but you can see now that I have a character control that's somewhat okay. I can move around the scene. I can slide around. I don't have head bob or anything like that right now. There's no footsteps, right? And later on, we'll see what we can do to download a character controller in 3D that allows us to do more than just this, okay? So that's kind of it. I can jump up and down. You can see I can jump and I land, and it doesn't look like I'm floating anymore as much as before because I'm falling down at 30 meters per second squared. That's what I'm falling, which is much faster than, let's say, 10 meters per second, which is great for physics simulations, but not great for games. All right, so this is the end of my controller. Let's save it. And I'm going to stop the video here, and I'm going to go into the next phase. So people who are watching me or waiting, if you want to stick around, I'm going to keep recording for another half an hour. If you can't stick around because you have other commitments, I'm totally fine with that, but I want to give you everything you need for this week, and that's why I'm going to record an extra half an hour or so, okay? So for the lab, you have most of what you need. The only part you need now is we're going to make another tile in Blender and bring it in, and instead of having this ground that we have here, all I'm going to do is I'm going to bring Blender's tile in here so we can actually move around the little tile, little maze that we're going to make, right, for us, which is going to happen. All right, let's save this. So File, Save, File, Save Project, and then I'm going to close this down. I'm going to go to our Gitkraken when Unity's closed. I'm going to wait till it's closed. And it looks like you can see that there are still doing its funny dance. Just wait for it to quit, okay? You don't ever want to quit Unity by itself or on your own without Unity clicking on its own. Sometimes it'll take a little bit of time. You can see that it's taking its sweet time to close. And what it's doing is sometimes it'll crash like this. You know, I'm just being honest, right? And telling you, like, Unity's not perfect either. It could also be a version that I'm using. It could be a lot of issues. But one thing I want to do is I want to see if it closes anytime soon. And if it doesn't, and if it's still busy like this for a while, put it up on Gitkraken anyway. All right, so I'm going to go to View Changes. You can see that I've modified my player behavior script and my main.unity, but there's no meta tags. And this is what I was waiting for Unity to close for. Because what happens is while Unity's open, I'm missing some additional, there you are. I'm missing some additional files, right? So it's important that you make sure that there's nothing that's open. Unity just closed. And let's close this too. And we're going to come back to this to make sure that there's nothing that's open. I'm going to stage all changes, and I'm going to go here to this. I'm going to say completed simple, that's what it is, FPS, first-person shooter type character controller. So I've given you this, and you're going to have it for the remainder of the semester, like I said. And we can add to it. We can download something else. There's lots of stuff we can do, but at least this way you have everything you need to get going with a player. Okay, I'm going to stop recording here. And the next recording I'm going to do is I'm going to talk about two things. I'm going to bring in a tile in from Blender, and then I'm going to talk about your assignment 1, part 2, which is something that's going to be due not next week, but the week after in week 4. Okay, so I'm going to stop recording now, and then we'll go from there.